All right, quiz 2. So quiz 2, we had trouble with this one. First thing, make sure you're adding lone pairs to all these things, right? That's the first thing. If you see a carbon with a negative charge as a carbanion, that has a lone pair, so make sure you add that lone pair in. This is very similar to a workshop one, the resonance workshop, the last one, the resonance workshop. So what I wanted you to see, there's a couple of different ways you could do this. There's no always completely right way. What I wanted you to see though is that you can take a lone pair, and that can make a pi bond, and then that pi bond can break, and then those electrons in that pi bond go to an atom, creating a new lone pair. Right? So you kind of start with a lone pair, make a pi bond, break a pi bond, end up with a lone pair. And of course, you need to balance your charge all the time. So you notice things are happening here. A couple ways you could have done this. You could have done it from forward. You could have gone backwards and said, well, this could have gone back this way, right? People did different things. Challenging to be sure. Number those atoms. Remember the charges. Don't do silly things. Start arrows at electron density. That's the biggest thing. So a good thing to remember is we always want to start our arrows where it's electron rich or electron dense. So like lone pairs, right? Places with negative charges, but you always start, remember electrons move. Bonds don't move, electrons move. So usually you want to start your arrows at electron density where it's electron rich. So lone pairs are good places, those kind of things. All right, so for the biggest thing for this one, what I saw, so it says label the hybridization states of all the atoms except the H's. So people forgot to label all the atoms. First, there's 1, 2, 3, 4, 5 atoms that need to be labeled. People forgot those, so make sure you do those. Looking for the number of pi bonds, right? No pi bonds, sp3, no lone pairs. 1 pi bond, sp2, 1 pi bond, sp2, no pi bonds, sp3, no pi bonds, sp3, but it has lone pairs, and that it's 1 bond away from a p orbital, so it's sp2, so that lone pair would be in a p orbital because it can do resonance. So don't forget that rule about resonance, right? Where if you have a lone pair and you're next to a p orbital, you want to do resonance. So you're going to have a p orbital because only p orbital electrons do resonance. So what hybrid orbitals are making the sigma bond between the box nitrogen and carbon atoms? Well, if this nitrogen is sp2 hybridized, it has an sp2 hybrid orbital to make a sigma bond. This carbon's sp3, so all it has is sp3 hybrid orbitals. So that's what it uses to make a sigma bond.